Yes, sir. Let's start now.
Okay, sir. You wanted to start with introduction?
Yes, sir.
Okay. Yeah. Hi all. Uh, Good evening and welcome to iitians Gate classes. So I am your faculty for your digital and so my subject expertise is our core instrumentation subject I used to teach. And then apart from that, optical is also a part of core instrumentation. Then analog and digital. Okay. So I have been there with Dinesh sir since 2019, and this is our we have started our gate batch for gate 2025. Okay. And the classes that we offer is among all the streams like our aerospace and then mechanical, electrical, EC, IN. Okay. And even we have started for our data science also. So we offer our gate online coaching, even crash course also we used to offer. We are having our own test series, we are having our distance learning program as well. Okay, and our batch is starting from 18th of Feb. Okay, so
Sir, CS
admission,
also.
yeah. CS also,
Yeah,
yeah.
because digital
So
is part of CSS. Yeah, please.
mhm, yeah, so irrespective of the number of students whatever we are getting, we used to put our effort, and the effort will be maintained throughout the year. Even after you have completed your courses, we used to guide students post our completion of the courses. Let's say if they wanted to join any PSU, so we offer even interview guidance program as well. If they wanted to join any masters college, so there also we used to support them in terms of the guidance, in terms of any technical lag they wanted, they are feeling. So post exam also, so it's not like if you enroll with us, then so 1 year we will be there with you and will not leave you. So i- at any point of time if you need support, so Dinesh sir and the team is there for with you, right? Dinesh sir, you wanted to add anything?
You have mentioned, okay. So, guys, here we don't work on numbers. We work on whoever join IGC with 100% success rate. uh, just only one thing you guys need to maintain is what sincerity, and you guys need to work hard along us. Okay, we have got our students in PSUs, in IITs, irrespective of branch which we teach. Okay, and so this year also it is same, but our core strength mainly is aerospace. We are number one in India for gate aerospace. So because of considering less number of institutes in India for aerospace, and my own background because I'm organizer for iitians Gate classes. So I have a strong legacy of producing best rankers, as well as in 2023 we got 70 plus students in IITs and ISC from our institute among all branches. So that's how we work. Yeah, with very limited.
Our students have also gone to multiple PSUs like ONGC, NTPC, so they have gone from our institute as well.
Yeah. In last session also we got one of the student in NPCIL before in Coal India. Anyway, in DRDO, HL, and BAIL, many people got it. So guys, here just trust the your learning will be very smooth and quality. No hola, no shero shairi, no unnecessary talks and all. And here it is not like one person is teaching, after 2 months you are not finding that person in that institute. So your learning get hampered. So here whoever teaches, they will be throughout year, and they have best academic credentials along with industrial credentials. So end of the day, you want to work in PSU or in core company, and here our team is already from there. So you will get very good guidance, okay, along with your academic learning. Yeah. So let's start, Akbar
Yeah,
sir, with
thank you, sir.
subject. Thank you,
So
sir.
this PPT I have taken from our classroom lecture, and in digital circuit. So if you go through the syllabus of our gate instrumentation, as well as EC and even electrical also. So digital electronics is common among both, all the three streams. Okay, and the combined class used to happen for digital electronics, analog, and
We have
whichever
not
common.
put CS syllabus.
Yeah, CS syllabus is also somehow more or less it is same only. So mostly the topics are, first will be your logic gates, and then second will be your boolean algebra, and then minimization. Third will be your combo logic, and then you start with your sequential circuits, and then you are having your data converters. Here we used to study our ADC and DAC, and then miscellaneous topics like our number system, then memories, and if any other small topics are left, so that we cover. Okay, so mostly the questions that are being asked from either boolean algebra, or the questions are being asked from the sequential circuits. Okay, so questions are mostly framed from these also. So sometimes the question are being asked from data converters also, right? So all these topics are somehow interrelated only, because you cannot design a sequential circuit if you don't know the basics of logic gates, if you don't know how to minimize any expression. Okay, so right now in this lecture I have taken a small topic of our boolean algebra, and so there we will see what is boolean algebra, and then how we wanted to minimize the expression, and what we wanted to achieve with the help of minimization. Okay, so since this PPT is from class PPT only, so generally in lecture 2 I used to cover this boolean algebra. Okay, okay, this is the basic question from gate 2022 EC. Okay, I have just taken a snippet of this. Anyone who can solve this question, please try and go ahead. Anyone who can try? Okay, so the what it is saying, select the boolean function equivalent to x plus yz. So x plus yz, this is a function, and what is the boolean expression equivalent of this, right? So we are having four options, a, b, c, and d, and we have to choose among these, right? So this question you can only solve if you know the minimization techniques, what all boolean laws are there, what all theorems are there, so that we are going to see here, right? Okay, so what is boolean algebra? It is a convenient and systematic way of expressing and analyzing the operations of the logic circuit, right? So let's say if you are having this circuit, okay, and this circuit expression is AB plus A into B plus C plus B into B plus C, right? So this is the expression of this particular circuit. Okay, and upon minimization, what you are going to get, you are going to get B plus AC. Okay, so why we are doing boolean minimization? First question is why we have to go for minimization. Okay, so why we wanted to go for minimization? Ultimately, if you see, if you wanted to implement this particular function, so all this will be implemented on silicon, right? Silicon, if you do not understand, then whatever the chip, whatever the IC, or whatever the chip that you have studied in your college, and gate chip and any other chip that are from multiple vendors like Texas Instrument and even Nvidia, Qualcomm, so all those companies are there, those companies are providing all these chips. So let's say on this silicon all this logic will be implemented, right? So this function will be implemented on the silicon. So when we talk about silicon, this will be a hardware, right? When you minimize this function and this function will be same, right? So what we have achieved here, we have achieved here cost reduction. Okay, same function is been implemented with this expression, right? B plus AC will work same as this long expression. Okay, and this long expression contains how many gates? 1, 2, 3, 4, and 5 gates. Okay, so 5 gates are here, and here 2 gates are there. So with only 2 gates, you are able to implement the same expression or same function that is being implemented with the help of your 5 gates, right? So this is how you are going to reduce your cost, right? Cost reduction. Ultimately this will be implemented on the silicon. And how this will be implemented? You would have studied in your college, right? This is your not gate, right? So from the logic circuit you have studied that this is your not gate, right? But it will be implemented as a CMOS inverter, right, on the silicon. So everything, each and everything that you design here as a part of your digital logic, that will be implemented on the silicon. So ultimately the aim of your Boolean algebra minimization technique is to reduce the cost of production. Okay, so if you reduce the cost here, ultimately it will reduce the cost whenever it will go to the customer. So at customer end this cost will be reduced, right? So that's how we have to understand what is Boolean algebra and how many techniques are there and how we can effectively use those techniques to reduce the expression. Okay, any doubts here? So this is the basic overview why we wanted to study this topic. Each and every topic is in the digital electronics is important, but you have to understand why we are reading this topic. Okay, so now if I give you a big expression, let's say if I give you expression like this expression, if I give you, will you be able to minimize this expression? If you don't know the rules, if you don't know the laws, theorems, right? So you won't be able to minimize this. So before that, some background is needed. You need to learn something. You need to learn how the minimization techniques works and how many minimization techniques are there and how we can effectively use the techniques to minimize this expression, right? So first we understood why we wanted to go for minimization. Now we have to understand how many techniques are there and how we can effectively use those techniques to go for minimization. Okay, so there are various laws, various theorems are there, right? So this is the basic Boolean addition. Boolean addition is equivalent to your OR operation, right? What is OR operation? Is a kind of in the mathematics it's equal to a sum operation, right? So here you can see this is your OR gate, and 0 plus 0 is equal to 0. So 0 plus 1, this will be equivalent to 1. 1 plus 0 is equivalent to 1. 1 plus 1 equal to 1, right? This is a very basic thing, so we are not going into details of this. Okay. Similarly, we are having Boolean multiplication also, and this is equivalent to your AND operation. So here 0 dot 0 is equal to 0, like that you are having all possible combinations of two variables, right? If you take a b and this is y, so what is the truth table of your AND gate? 0 0 0 1 1 0 1 1 0 0 0 and 1. If any one input will be if both inputs are 1, then only your output will be 1. Okay, so there are basic rules of Boolean algebra that we need not to mug up. This will come with only practice, right? This will come with practice only. If you're going to practice a lot of questions on minimization, then all these formulas, all these concepts will be automatically remembered. Okay, so a plus 0 is equal to a, this is your OR law. Okay, a plus 1 is equal to 1, this is also your OR law. A dot 0 is equal to 0, so anything multiplied with 0 is equal to 0, right? A dot 0 is equal to 0, right? So a is a literal, this can be 0 or this can be 1, right? So 0 dot 0 is equal to 0, 1 dot 0 is equal to 0, so this can be anything, right? So same way all these rules are there. So a dot 1 is equal to 1, so this you can either read it as dot or you can read it as the and. Okay, plus this you can either read it as a plus or this you can read it as or, right? So what I told, and is equivalent to multiplication and or is equivalent to summation. Okay, in the mathematics. Okay. So similarly, a dot a is equal to a dot a bar is equal to 0. So this is important formula. And if you take double negative, then this will be a, right? If this is your a, if you take one negative, one not get, negative, not get, invert, all are same. Okay. What does this mean? If you, for a particular circuit, if this is a not or inverter, if you feed 0, it will give as 1. If you give 1, it will feed as 0, it will give output as 0, right? So a, one time invert, it will be a bar, another time invert, it will be equal to a. Okay, so a double invert is equal to a. Okay, a plus ab is equal to a. Okay, a plus a bar b is equal to a plus b. So these all are the basic rules that you have to, I cannot say you should be remembering this, but you have to keep this in mind, and this will automatically come with practice whenever you're going to solve as many questions as you can. Okay, now there are certain important laws of Boolean algebra that we have to keep in mind. Okay, so there are three laws. One is your commutative law, then you are having associative law, and then you are having distributive law. Okay, so commutative law, what does it say? It say that a plus b is equal to b plus a. What does this mean? The order in which you're adding the variables, let's say either you are adding first a plus b or you are adding first b plus a, both results in same, right? So here what you can see, this is your or gate. So either you add a plus b or you can add b plus a, both will result in the same expression. Okay, so the commutative law, this will also holds good for multiplication of the two variables also, right? So here also it says a dot b is equal to b dot a, right? Or a and b is equal to b and a. Okay, so what does this mean? The order in which your variables are multiplied, variables are anded, this makes no difference, right? So here you can see this is your and gate. So either a and with b or b and with a, this will result in the same expression ab. So ab is equal to ba. Okay, next is your associative law. Okay, so associative law, what does it say? It say that, let's say here a plus b plus c, okay, and then is equal to a plus b plus c. Okay, so the way you can group the variables, let's say first either you can add b plus c first and then add with a, or you can add a plus b first and then you can add c, both will result in the same. So here what you can see, there are three variables a, b and c. Okay, so first you are adding b plus c and then finally you are adding with a, this is resulting in one expression. Okay, in the second thing, in the second time, what you are doing, first you are adding first two literals a and b and then you are adding with c. So this is also resulting in the same expression. So both expressions are equivalent or both expressions are same. So this associative law, this will also holds good for your multiplication also. So a into bc is equal to a dot bc, right? So the way you are anding, the way you are multiplying the variables, it will not make any difference, right? So same way it will holds good for your multiplication also. Next is your distributive law. Okay, what does it say? It say that a into b plus c is equal to ab plus ac. Okay, so b bc, this is b plus c and then you have to end with a, this will result in the ab and ac and this will also result in the same expression. Okay, so if you go to reverse way, then this will call, this we are calling as factoring, right? So we are, you are taking a here common and then this will becomes b plus c. Okay, and then you are having certain theorems like duality theorem is there, and then you are having your complementary theorem is there, so that also we are going to see. So what does duality theorem says? It is obtained by interchanging the logical and operator with your logical or and on zeros with one, right? So what we are going to do here, you have to change or to and then and with or, right? That means 0 to 1 and 1 to 0, and then finally, but here you have to keep in mind that you do not have to complement the variable. You do not have to complement the variable. For example, let me write here, you do not complement the variable. Okay, for example, if you are taking, let's say, function is there, ab plus a bar b plus a b bar. Okay, so if I say find the dual of this expression, find the dual of this expression, so how you are going to find the dual? You have to look to the duality theorem. So what does duality theorem says? If there is any or, you have to convert to and, means dot will be converted to plus, and then plus will be converted to dot. So here what you can see, a is there and then b is there, and both are anded, right? A dot b is there. Okay, then plus a bar dot b is there, plus a dot b bar is there. What does it say? Do not complement the variable, so a will be as it is. Okay, dot will be converted to plus, so a plus b. Okay, so ab will be converted to a plus b. Now this or will be converted to and, or plus will be converted to dot, right? Again, a bar dot b, do not change the variable, so this will be a bar, this dot will be converted to plus, and this will become b. Okay, again there is another or, convert it into and, plus will be converted to dot. In this expression, do not change the variable, a will be as it is, dot will be changed to plus. Okay, and then b bar. So this is going to be your dual expression of this particular expression, right? So both expressions are dual. Okay, now you can take another example. Let's say take this a plus b bar into c plus d. Okay, find the dual of this. You can type your answers in the chat window, or if you wanted to speak up the answer, you can speak up. This is very easy question. If you understand the concept, you can solve. Okay, so how we have to find the duality? Do not change the variable, so a will be as it is, right? Do not complement the variable, so do not complement the variable, a will be as it is. Okay, this is what, this is your or, right? Plus or will be converted to and, means plus will be converted to dot. This is your b bar, do not complement the variable, let it be as it is. Again here hidden dot is there, so this dot, this is your and, right? This and you have to convert to or, and then do not complement the variable c, this will be dot, and then d, right? So this is your dual of this particular expression. Okay, then attached to dual there is one complementary also. So if you want to find the complement of a function, then you have to complement the variable, right? So let's say if you want to find the complement, so how you can find the complement? This will be your duality plus complement, duality plus complement. That means and will change to or will change to and then you have to complement the variable, complement the variable. Okay, next comes very important theorem, that is your De Morgan's theorem, right? So what does De Morgan's theorem says? This is the product term, right? Xy. So you have taken the complement of this, so the complement of product of variable, this will be equal to sum of complement of the variable. So a dot b bar is equal to a bar plus b bar. Okay, you can either say a bar, or you can say a invert, or you can say not of and not of a, right? So any terms you can use. So a dot b bar is equal to a bar plus b bar. Okay, and then same way, a plus b bar, this will be your a bar dot b bar. Okay, so these are the two theorems of your dual De Morgan's theorem, right? So first theorem, what does it say? Complement of the product of variable is equal to sum of the complement of variables, right? So this is your theorem 1. Okay, so here how you can see how it is implemented: xy, and then you have taken the NAND operation, and then this is become xy bar. Okay, so both side you are proving, right? You can see here xy, you have taken all four possible combinations, so xy bar is equal to same as your x bar plus y bar. So this is how you can prove that this particular these both expressions are same. Okay, so next, the second theorem is same as this one I told. So you can remember either this or this, both variables are same. So a plus b bar is equal to a bar dot b bar. Okay, so complement of sum of variables, this is equal to product of complement of variable. Okay, so NOR operation is equal to negative AND. So here you can see four possible combination: x plus y bar, and then this x bar y bar. So both are same. Okay, now we will come back to our original question, right? Try to solve this question. This is your gate 2016 instrumentation question. How we can approach this question? Okay, so what does it says? The Boolean expression is xy plus x bar plus y bar, okay, into z. Any answers? Anyone? Okay, what does duality theorem says? Or we can apply De Morgan's theorems, right? What does it say? X bar plus y bar is equal to xy bar. Okay, so a plus b bar is equal to a bar dot b bar. Okay, and then a bar plus b bar is equal to a b bar. Okay, so here what you can see, if you apply De Morgan's second theorem, then I can convert this x bar plus y bar to xy bar, right? So this will be xy plus xy bar into z. Okay, any doubt here? No. So this is your second theorem we applied. Now you can see here there is one theorem, that is x plus x bar y, or a plus a bar b is equal to a plus b, right? Let me go back to basic rules. Okay, if you see here rule number 11, what does it says? A plus a bar b is equal to a plus b, or x plus x bar y is equal to x plus y. Okay, you got it now? A plus a bar b is equal this. So this rule is nothing but your redundant literal law. Here what you can see, one term is redundant. Okay, so uh, where is the question? Yeah, so a plus a bar b is equal to a plus b. So if you consider this x and y multiplied as one variable, this is one variable, and then complement of variable multiplied with third variable, a plus a bar b, right? You can consider this as one variable, and then complement of a variable, and then third variable, right? So this will become a plus b. So similarly this will become xy plus z. Okay, so this is how we have simplified our boolean expression, right? But in the answers we are not seeing that which is the correct answer, right? So we have to match with our simplified expression, right? So now you have to match which one is matching. So first one is xyz bar plus x bar y bar z, right? What is common here? It is difficult, right? Here also there is nothing common here. Then third you can factorize this, right? You can factorize this, so this will become xy plus xz plus zy plus z into z. Now basic rules you have to see. Basic rules you have, if you see, then how we are going to minimize this. Z into z, this will be z, right? Z into z is z. Okay, you guys are getting, or any doubt is there? Okay, so let's take this expression. If you are taking xy plus xz plus zy plus zz, so z into z, this will become z, right? Zy plus xz plus xy. Again, if you take z common here, then 1 plus y, right? Z into 1 plus y, this will become 1, right? Again you take this common, so z into 1 plus x, this will become 1 and this will become z, so z plus xy. So that's how you have to go for third option. Okay, so this is how, if you study, if you know how to apply the proper boolean laws, boolean theorems, then you can definitely solve the questions, right? So you can apply the De Morgan's theorem, you can take this question. So in our live interactive class, we used to solve these questions together, and whatever the doubts are there, that we used to take. Here it's I am seeing that it's a one-way communication only. So this is how we are teaching in our class, and this is your class PPT. Maybe if I go next slides. So there are ample of questions that we used to solve. So you can see here questions are being solved like this. Okay, so we used to discuss and then we used to solve the question. So some response we are getting from students, and then how they are solving and how they are approaching and what is our approach. Okay, and then some assignments questions are also there, that again next day we used to discuss. Okay, so there are ample questions that we used to practice here, so that in your actual gate exam there won't be any problem. Okay, fine. So we'll take some one or two questions, and then we can wrap up our class today. So if you understood the De Morgan's theorem correctly, try to apply this De Morgan's theorem here. I will again go back to De Morgan's theorem. What is it says? Complement of product of variable is equal to sum of complement of variable, and second is complement of sum of variable is equal to product of complement of variable, right? So you can see a plus b bar is equal to a bar dot b bar. Okay, and then second law is a dot b bar is equal to a bar plus b bar. So same way, if I take the first question, then first question is a plus b bar plus c bar, and then another bar is there, bar or in what you can say any term, right? Try to apply the De Morgan's theorem here. Okay, so here what you can see, how the rules are there. Let me change the color. So this is your a plus b bar is equal to a bar plus b bar. A plus b bar is equal to a bar dot b bar. So what we are doing here, so this invert we are removing, and then once you remove this invert, this plus will be converted to dot. So this will be a bar and then dot b bar. Okay, right? So here also, let's say if you wanted to remove this first invert logic, then this bar will be splitted into two, right? So this will be a plus b bar, original one, and then this plus will be converted to dot, and then c bar. There will be one bar this side, one bar this side. So negative invert. Okay. Again, this you can also minimize. This also you can minimize. Okay, if you know the rules, right? So c double bar means dual invert, this will become c, right? We have seen that a dual invert, this will be a, so this will become c. Okay, and then this also dual invert, so this final minimized expression is a plus b into c. Okay, what we have achieved here, why means whenever we have minimized, okay, so what was our original expression? The original expression was a plus b bar plus c bar, and then another bar is there, right? And we have minimized these to a plus b into c. Okay, what we have achieved here? Okay, some answers are there, a bar, b bar, c bar. Okay, okay, no problem, good try. Okay, so what we have achieved here, let's say this particular logic, if you wanted to implement on a hardware, on a silicon, then how we are going to implement this? A plus b, right? And then bar, right? Another invert. Okay, or we can take here nor as well, right? Anyway, implementation wise it will be same only, number of hardwares it will be same only. A plus b bar, and then another c will come from here, again invert, this will become c bar, and then you have to take the nor of this, right? This will become a plus b bar plus c bar bar. Okay, so here your one or is there plus one not is there, here also one or one not is there and another not is there. So how many? Two or, then three not is there, right? So how many? Five gates are there here. Here what you can see, a and then b you can implement with one AND gate, and sorry, this will be OR gate, a plus b, and then you can use one AND gate, right? So this will be a plus b into c. So what we have achieved here, we achieved the cost reduction, right? How we achieved the cost reduction? By reducing the number of components. When we reduce the number of components in the logic, the number of components that gets manufactured or gets implemented on the silicon through the fabrication process that you might have studied in your college, that is a lithography process. So lithography process, this way you are going to implement this. So when you have implemented on silicon, this will become with two gates only you are able to realize the same expression that we have realized using five gates, right? So there are various techniques. Let's say the basic Boolean laws, Boolean algorithms, everything you studied, and then also let's say you are not able to minimize this. Then there are various techniques, right? You can use your K-map. That is also a systematic approach. So that will also give the minimize expression. So that is also a effective way of cost reduction. Okay. So maybe you can try all these questions at home. Okay, and there are various questions as well, so this will anyway come in recording. You can solve these questions. A b bar into c plus d, c plus bd plus a bar b bar into c. right? So first you can use the distributive law. Okay, so you can distribute this will become a b bar c plus again a b bar b d. Okay, then a bar b bar again multiplied with c. Okay, so here what you can see, b bar b, so b bar b, this will become 0, right? So the whole term went to 0. So finally what is remaining, a b bar c plus a bar b bar into c. Okay, so again you have to multiply inside, so this will become a b bar c plus a bar b bar c. Okay, what is common here, b bar c is common. If you take b bar c common, then this will become a plus a bar, and a plus a bar is nothing but your 1, and this will become b bar c. So so all these will come as your rules only. So if you study the rules, if you know the rules, then you can solve this, right? I'm not saying that you should remember all these things. All these things will only come with practice, right? So in our class, uh, we used to solve around 90 to 95% of your pyqs. Okay, so 90 to 95% of all the pyqs that we used to solve in the in class only, right? And that is not like, let's say if I give you one question and then I will only solve. No, so this will be a live interactive class where I will teach you the concepts, and then you will try to solve. I will ask you how you have solved, what is your approach, and okay, this is something different you tried. Okay, how you tried, what you thought, right? So this is a complete interactive class. It's not a one way delivery that I am just delivering the lectures and then you are getting it. So it's not like that. Okay, so post our class we are having the certain platforms like Telegram, WhatsApp, and all those platforms are there where you can ask your doubts. So let's say in this only, if I have given you 4 or 5 questions in the assignment as a assignment, you need to solve those questions, and then you have to, before the start of your next class, you have to come back with the solution. Either you send back, or in the live class only you have to tell, okay, this way I have approached and this way I got this answer, right? And then you have to match with the way we used to solve, right? So this class is a completely live and interactive classes, right? And then we used to solve 90 to 95% of the pyqs. If you practice all this question in the class only, then you can understand that, right? Last 25 years if you have solved all the questions, then there are chances that whatever the question that you'll get in the gate exam, that this will be pretty similar to all these things, right? Somebody have given some answer, a b bar plus c bar, c bar plus d bar. Yeah, I think this might not be correct, but anyway, good try, you tried at least. Okay, fine. So uh, with this we will wrap up our today's session, and then hope we will meet in the live lecture. Okay, any doubt, anyone is having any doubt? Dinesh sir, you're there?
Yeah, so timing will be 8:50 to 10:50. Weekdays, Saturday it is evening, 5:50 to 7:50. Then again night 8:50 to 10:50. Sunday morning 10 to 12. So you can ping us in WhatsApp, Sasidhar. We'll share that timing.
The way the management is planning all these things, all these timings, so those plannings are, we plan like that, whoever is working in a corporate or whoever is studying or whoever is, so it is, so this whatever the timing that is there, this will be suitable to all those people who wanted to join our classes, right? So let's say on our weekdays we are having evening classes post 6 p.m. or 5 p.m., right? So their corporate timings are over, and even colleges are also over, and on weekends we used to plan somewhere in the midday.
No, no, no,
So the
sir.
timing, uh,
Sir. Timing, what you're telling, evening we don't have, na? We have night 8:50 to 10:50.
that's what means, it's a out of corporate time, right? out of
Yeah,
college
yeah,
time.
yeah.
And
But I
so
think
this
you were
is
telling 7, 6, right?
okay. So timing might be means we the planning we are doing like this time
Yeah,
will
everybody
suitable for
can join,
everybody
whoever
can
is
join. Yeah,
active.
correct.
Mhm.
Hmm.
And also timing will be flexible, not that hectic. Okay, so easily, people can join classes, live classes, and then they will have time to recap live classes or solve assignments and practice question. And Monday and Friday also we give off for fab batch, so you guys can, whatever Saturday Sunday done, Monday you guys can recap, and whatever from Tuesday to Thursday it is done, Friday can be recapped. So any other concern or doubt, guys, in terms of the approach of classes or in terms of the quality of the classes? And guys, be free to respond, either at least respond in chat. If you don't want to speak, you guys can speak also while joining. If you join with microphone, you can speak during classes. Vinay, you can speak because you have joined through microphone, right? So there are two options while joining classes. One is listen only, another is microphone. Anyway, we will introduce on Saturday with all these things before starting first class on Sunday. So Sunday is going to be first class. Yeah. So anything else, guys? It's clear, right? So yeah, and another update, we will have further doubt classes, further these demo classes on Thursday and Friday also. Thursday for ECEE signal class is there. For Gate CS, we have planned class for data structure algorithm. And on Friday, mostly another class will be there for discrete mathematics for CS group, and for EECIN, I'll update which class. Saturday morning also there is one class, EMFT basics. So like this, there will be few more demo classes before starting first class on Sunday for engineering math. Okay. Anybody else? Any doubt, concern? Okay, guys. So, Aditi, you have any doubt, concern? Yeah, now you can speak out, Aditi. Vinay, anything?
So Sunday onwards, regular classes are there, and
Yeah,
timings will
regular.
be
Yeah,
as
yes. So,
a weekend
yeah,
timing.
weekends.
Okay.
Timings I have mentioned na, in that brochure and introduction to course. There
Yes,
also
yes,
we
yes.
discussed about time. So we will follow those timing. Initially, maybe 1 or 2 week classes may go little slow. Okay, but March first week onwards, it will be full fledged classes.
In this video interaction, I didn't get how to chat.
You go and click on na public chat.
That is not visible for me.
No, no,
Chat.
just you are using mobile now. So in mobile, you
Yes.
can see there is a human symbol. Click on that human symbol on top.
Okay.
If
Okay.
you
Okay. Okay.
So
Okay. There
these
is a public
classes
chat.
are accessible through mobile, through laptop, or through tab because it's a browser-based tool. And recording will be also there in the same class link. Okay, so it will be very systematic, and you guys will get HD recording. Will be very high quality recordings. Yeah, you want to ask Aditi something? You are writing, so you can tell. Yeah, Anamga, you have any doubt? You were asking books and all right that time. So once classes start, you can ask respective faculty subject books.
Dinesh ji, any material will be given from your end?
Yeah, we give material. It will be given in e-form, sir.
E-forms. When you will give that one? How to get that one?
How to? That through Google Drive we will share. Aditi, don't worry. We will teach every subjects in a particular number of hours. Okay, nothing pace will not increase. We have enough time. Okay, in fact, we cover very well syllabus for July batch also. So pace means it will be moderate pace. And already we use semi PPT approach. We focus more on explaining concepts rather than writing everything in classes, because since it's an online class, so we have luxury of keeping some pre-prepared content. So Aditi, not to worry about completing syllabus properly or in terms of the pace of class, it will be as adjusted with the students requirement. Clear, guys? uh, Actually, I am not like director and all, Utpal sir. um, Basically, I believe I am an organizer for IGC. We are a team. Of course, I have been in lead role from long, but we are a team. Okay, here we don't have such post in IGC, directors and founders and all. Personally, Utpal sir, I don't believe in that. Okay, and I
Okay,
am a
okay.
core mechanical, aeromechanical faculty, come organizer. You can see in nowhere we believe that, because this institute or this platform is for both side, whoever is a passionate teacher and whoever is a passionate learner. Okay, so Vinay sir, you have met us, right? So our idea is to provide what is required for any good sincere student, and we are a very good team of 40 plus people in IGC currently, Utpal sir. There are few things where we are currently not focusing. One of that is marketing. So in future, of course, we are going to work on that. Yeah. Any other thing, Aditi? Is it clear now? Your doubt is clear? Yeah. Fine then, Utpal sir. Vimal Raj, any more doubts? Sosidhar, any doubt, Vimal Raj? Okay. I think, sir, thank you, Utpal sir. We are done, and we planned this for 1 hour, 1 hour. So I think almost 1 hour is done, and let's sign out, if no doubt further.